quiet all of a sudden. Okay. Should we start? All right, so good morning, everybody. My name is Pierre Parisi. I'm the Vice President of Business Development for Apergy Digital, and welcome to the webinar. Today, we're going to cover at a high level how our remote operating centers work. We'll cover the technology that enables it, and we'll do an in-depth tour of a day in the life of an analyst, followed by a demo. So we'll kick off with some introductions as well, and also we'll go with a safety moment as well. So Saliu Kone has been with our company for a little over a year. He's our digital services leader, and he's responsible to expand and scale up the digital services offering. So he also comes from a background in this area, and we've been very fortunate to have him on board. Hope you can learn a lot from him. Pete Flanagan has a little longer tenure with us. I started with Windrock, which is one of the Apergy companies, in 2015. And he is actually one of the subject matter experts. So we'll go through a lot of the squiggly lines and all the detailed stuff that provides a lot of insights. So I look forward to that. Myself, my name, as I said, is Pierre Parisi. I have about 30 years experience in asset monitoring. And with different companies. I started with the Bentley, Nevada. I was there for about 10 years, responsible for sales and services for Latin America. Also 10 years with General Electric and a couple of other companies. I've been with the company for about 3 years now. And I'm responsible for the digital, the Apergy digital portion of these remote operating centers. Next slide, please. Safety moment. Most of you may have heard of this. Zoom bombing is actually something that has happened in some of these situations. There's the definition. It's an uninvited guest that hacks into a meeting and disrupts it. Hopefully, we will not have any of that, and hopefully, folks who are started enjoying this as a pastime will find a better way to occupy it and use their talents. But in case that does happen, we will turn off the webinar and we will schedule. So I will pass the baton to Saliu right now. I may jump in here and there for a couple of comments. Saliu, the screen is yours, and let us know about the remote operating centers.
Thank you very much, Pierre. Good morning, everyone, and thank you for attending our webinar. My name is Saliu Kone. I'm the digital service leader here at Apergy. And as Pierre mentioned, I've been with the company for about a year. I am mainly responsible for our remote operation center and also for refining and executing our overall digital portfolio. So today we'll be talking about our remote operation center. So we currently have 3 remote operation centers, one in our Woodland office here in Texas, one in Odessa, Texas, and the third one in Knoxville, Tennessee. We are currently working with partners in a different geographical region in order to establish some additional remote operation center. So we are planning to open one in India and working with partners in China as well. So here in our remote operation center, we rely on a few operating principles, and our product literally offers a total asset visibility to our customer, meaning that they have the ability to access the data and trends about those data on the 24/7 schedule, and they have the ability to also access it via the use of a cell phone, tablet, or computer. We constantly work with them in order to optimize their work and their reliability plan. We help them make better decisions, and also we apply our AI and predictive analysis to the data being collected. We also collaborate with them on a constant basis, so we look at the process and other conditions affecting the operation. So as some of you probably heard, our latest collaboration is with DCP. So technology enablers. So how do we actually enable our remote monitoring? So we are able to enable our remote monitoring via the use of our enterprise cloud software. So what is enterprise? Enterprise provides actionable insight and predictive advisory to customer. So it can be literally connected to most industrial assets. So he also offers a modern and dashboard customer can analyze trends and also gain some very immediate insight about the health of the assets. So how do we do this? So we leverage our edge technology by connecting and tapping into all of your assets and then connecting those data directly to our subject matter expertise. As you guys can see, we have quite a presence in multiple areas, so condition monitoring, downhole monitoring, chemical injection, portion of the business, well site automation, and our newest service that will be coming up soon, the H2S removal system.
And if you don't mind, maybe let me jump in and offer a couple of other considerations on this. The importance of the remote operating center is that to really be the bridge between the assets that are in the field and the data that is typically stranded and the experts, right? So these can be our own experts, can be customers' experts, but they can even be third-party experts. So we have this vision using this technology and this structure to be able to actually access the knowledge of people that are not necessarily tied to those specific assets. So this kind of enables access to knowledge that goes well beyond what we may have in-house or our customers may have in-house.
Right. Thank you, Pierre. So typical application. As I mentioned, we have a presence on the well site monitoring and midstream monitoring. So we do provide a full automation offering consisting of equipment, software, and IoT solution for mainly downhole monitoring, production enhancement, as well as midstream skid monitoring. And today's presentation will do a demo on the midstream skid monitoring. So we, regarding the midstream monitoring, so what we do is we offer a total skid monitoring when it comes to this area. So all devices take measurement related to vibration, temperature, power cylinder, valve, trend, turbo health, and so on. So what we do is we take those data and connect directly those data to our subject matter expert that will monitor those assets and also analyze those trends. And what we do is whenever they find any specific excursion or any genuine event, they directly reach out to our customer and write a report regarding the effect of those events and anomalies. So we mainly look, when it comes to the compression skid, we mainly look for the compressor, we mainly look for mechanical looseness, in-cylinder gas leakage, excessive rod loading, inadequate rod reversal, high end and crank end pressure, crosshead vibration. We also look, when it comes to the high-speed engine, we look for bended and frame vibration, valve train health, cylinder peak firing pressure imbalance, mechanical looseness, piston slab, liner and ring issues. We do have a partnership with a company called Monico. So we offering a EDL data link, an engine data link called EDL. So what EDL does is EDL can tap into data and insight from Caterpillar engines and Waukesha engines. We also have a partnership with a company called CPI. We leverage also the lubrication application and tool in order to correlate those lube data to our compressor and also reduce the loop cost. As I mentioned in the previous slide, we do have a partner with CPI. So we partner with CPI in order to offer a very comprehensive package. And this partnership guaranteed a lower total material cost and operating cost to a customer. And as you guys can see on the screen, we have our EOS ProFlow pump that is connected directly to our gateway and our software.
So let me maybe add a couple of comments on that. One of the main reasons why parts, especially valves, fail is over and under lubrication. So this partnership really makes sense. We started with them about a year ago, but that the lubrication system is tightly integrated into the system. So we see the cause and the effect related to the premature use of the consumable parts. So we're able to control things through the system while we also monitoring them with Spotlight. Also, as this information then becomes available, you now have a real live view, for example, of pressure volume cards that will tell you about the health of the valves, the liners, the rings, etc. So this enables you to change parts only when they have to be changed, rather than doing that on a run to failure base or on a time base. So the optimization of this compressor lubrication system enables real-time assessment of the health of your consumables. That means lowering your total cost of ownership by extending time online. So that is what makes sense here in terms of the partnership, is not just simply integrating data. There's actually a tangible result that comes out.
So we tailor our services based on our user needs. So we have 3 service offering: a monitor package, analyze package, and optimize package. So the monitor package is mainly dedicated to customers who have enough subject matter experts and data analysts on their side. The analyze package is mainly consists mainly of our direct in-house subject matter expert looking at your data, analyzing data, and also trying to prevent any catastrophic damage happening to your assets. And the optimized package is our premium package. That's where we apply any AI modeling and predictive analysis to it, on top of having also a fleet benchmark report. So I'm not going to let Pete talk to you guys about what it's like to be a digital service analyst in our remote operations center. Thank you very much. Pete, can you go ahead?
Pete, you're on mute.
The old talking on mute trick. Hi, my name is Pete Flanagan. A lot of people on this attendee list I recognize, so a lot of people will probably be familiar with me. I have been with Windrock since 2015, and I'm currently looking at the majority of the compressor data coming in from Spotlight, and I'm going to kind of just do a walkthrough on how we go through and look at all of these pieces of data coming in, how we use the tools available to us. So for starters, we have the big picture. Each of these assets essentially has a home page in the enterprise environment, and that page has all the key information if you want to dig in deep to one specific asset. This page here will have details like whether the machine's running or not. It'll have information about who we would contact about this machine within your company, who your company would contact if they wanted to talk about this machine to us, what kind of machine it is, what package it is, how often the unit is typically serviced, maintenance intervals, that sort of thing.
Hey, Pete,
and then
can you share the presentation?
Am I not sharing the presentation? Hold on. Sorry. Thank you for chiming in, Dylan. share. All right, let's try this again. All right, can you see me now?
We can see you now, Pete. Thank you.
Thanks, Dylan, sorry. So we have information here at the top, again, is the information on this particular asset, just key information there. And then we have some key performance indicators as far as for compressor, it shows your efficiency, it shows your alarm count, horsepower utilization, capacity. The bottom of these little tiles here are actually real graphs of this information. And then we basically lay our cards out on the table for you here, and we say, this is every one of these little bars here represents whether or not a data packet has been received for each hour. So you can see whether or not your asset is communicating, and whether or not we have any performance-based indicators or performance-based alarms that have been triggered. And then we also have a graph for the hardware of the equipment measuring the data. And that is all laid out here as well. And this is the last 7 days with every single hour represented. And then there at the bottom, you have just a couple different trend graphs that gives you horsepower, capacity, whatever it is that's appropriate to the asset. And then farther down on that page, and then we start to get into specifics of what might be going on the unit. We have a tile that will report any active alarms. We have a place to upload documents such as reports or photos of the unit. The one thing that's important on this is this page here that we're looking at internally in the ROC is available in the exact same format to the customer. So the customer can upload documents as here as well, and they can view any of the documents that we've uploaded. And then we also lay out our health status. So we start off with, again, this is the finer detail of the hardware health, and we give you information about the different checks we do on the hardware to make sure everything's working and accordingly that your data can be trusted. And so something like this first one here, compressor mag pickup indicator, that's your speed sensor, and we take a vibration measurement on the machine every single hour, regardless of whether it's running or not. And so if we notice that we have no RPM, but we are getting indication from the accelerometer that there is vibration occurring, then we have a insight that the mag pickup is not providing feedback properly, and you get a little flag there. And we do checks like that on all the different pieces of hardware as well. And then below this, if you had any at the time, you would have user-defined alarms, which are your performance alarms. And we'll see some of those in the live demo here in just a minute. So we take this data and we basically look at it in a couple different stages. First, we have a AI system, which is an anomaly detection model that is sophisticated enough that it can not only detect an anomaly, but it can actually tell you about that anomaly, what the system is seeing. And we call it Kenny, and that stands for Knowledge, Enterprise, and Insights. So we're using Enterprise to gain knowledge and insight on your data. And so this model will report out on every cylinder. And there's actually a little tab we'll see later below the bottom of the detail page we were just looking at that gives your overview for each cylinder. And it looks at a bunch of parameters, a bunch of things that a typical analyst might not even look at. But if it sees a correlation and has a whole bunch of information it looks at, and it will report out a confidence level and a severity for each cylinder as to what it sees potentially happening there. And this is actually predicting what we expect to happen. So in this case, we see that there's something that looks like is already going on. So it's continuing to predict that it's going to continue. If it sees indication that it's going to possibly break through to a next level leak, it'll show that it's predicting a level 3, even though the current data may only show a level 2. And the really great thing about this is we have the ability to come in here as the data analysts and verify this and give feedback to the system. And then we have a feature in development where the customer will actually be able to use the same interface and provide feedback about findings that are discovered when action is actually taken on the recommendations and data that we've given. And we'll look a little bit more into this here in the live demo as well. And so once we've predicted things, now of course, not everything is going to get taken care of before it breaks. So we're going to actually see the faults start to occur in the data. And so for this, we have a couple different tools to do early detection of these faults. The first one is up here in the top right corner. Enterprise has a analyze utility that's in place, and this allows you to build group plots, just like the people who are familiar with MD will recognize, where you can put certain sets of trend points that make sense together, pre-plot them, so that way when you pop in here, you can see a trend of your flow balance or your N ratio or your leak index or whatever it may be. And you can see if you have, something starting to change. And this is, of course, customizable to any date range that you want to pick. And then we also have built into Enterprise an advanced analysis utility. And what this does is this will actually create a live dashboard for you. So you can pull up the dashboard on your asset, and this is what we do in the ROC. We have 5 large screen TVs in each one, and we have different dashboards. Again, all of the dashboards and all the stuff we're going over here is 100% available to the customer, and we're using the same data in the ROC, so we're not hiding anything at all. We're using the same information that we're showing you guys. And you can pull up this dashboard, and you say you have a monitor available or a TV in your office, and you have an asset that you're concerned about. You can pop up this, and you'll get live readings of whatever the current reading is, and then a trend graph as well. And we can plot any of the trend points for this. It's completely customizable, so you can tell us what you want in here, and we can build it exactly with what you want to see. And this lets you see in real time without having to refresh or go in and re-download data or anything like that, exactly what's going on. So this is something that we've used to monitor pocket unloader activity. We've used to monitor high vibration due to a change in loading conditions, where vibration will start to pick up, and we know it's an alarm level, but we want to monitor, if it's rising and that sort of thing. And so we can come in here and turn this on, and it will, live update for you all the time. And then we also have our industry standard, our industry leading software, Winrock MD, which is for machinery analysis. And this is where we can view the raw data that is generating all of these calculated trends. So the data in Enterprise is measured and calculated from the raw data. And then from that raw data, we can make a lot of information. So we take head-end pressure, crank-end pressure, we take vibration measurements and temperature measurements. We know how fast the machine's spinning, and then we also know the physical environment that this gas is being compressed in. And with that, we can take those basic data sets and do a ton of extra calculations, which are the trend points that you see graphed here and here. And so, of course, if you want to look at a trend, you want to know that that trend data is correct and believable. So we have a way to come in here and do more in-depth analysis, validate all of the data. Anytime we make a call on something, we always go back to the source and make sure that there's nothing strange in the data causing that, so we can be really confident in the recommendations and the observations that we made to the customer. We'll get into that a little bit more in the live demo as well. So once we have all this data coming in, it's all great and fine, but if you have 100 assets that you're watching, you can't log in every single morning. Can we unmute someone to ask a question? Pierre, if you want to chime in here?
No, go ahead, carry on.
Okay, sorry. So, we have all of this data coming in. If you have just one asset, you can manually review the asset every single day. But of course, we want to be able to look at more assets at a time than just one. And so the way to do that is to have every single piece of data point that comes in for every single machine goes through a series of checks on an alarm engine. And we can check to make sure that if certain conditions are met, we get told about it right away. And then we know that we can focus our attention on the machines that need attention, rather than focusing attention on machines that may be perfectly healthy. And so when you have a new asset, we have a couple default alarms that are set up. Anyone who is familiar with compressor analysis will be familiar with the concepts of flow balance, N ratio. Leak index is actually our first foray into AI. This is a trademark indicator that we have here at Winrock, and that allows us to do some unique analysis of the PV curve to predict faults. We also look at vibration, and then if you have supplied the correct information during the onboarding process and we have all the appropriate weights for your machine, we can also alarm on rod load and non-reversal or pin reversal as well. And those are our basic alarms, and that allows us to just kind of do some basic checks, the same thing that a typical analyst might do if they're just scanning through a compressor report, but we only need to look at it when we know something is crossing one of those thresholds. On the right there, you see a typical set of alarms for one cylinder for the basic default alarms. And we'll get into on the next slide that we actually have the ability to make much more complex alarms. And the benefit of that, of course, is reducing notifications that you don't need to know about. The more refined you can make your criteria, the less notifications that you'll get that you might not be interested in. And then, of course, getting all these alarms are great, just like getting a bunch of emails in your inbox is great. But if you can't archive something out of your inbox in your email to know that you've taken care of it, you end up with a really large list of actions and you can't keep track of what you've done and what you haven't. So the alarm management system comes into play here. And this allows us to take something that is a continuing condition, like a valve leak, and we can snooze that alarm. We can put a comment in there and say that we've notified this person at the company, or this person at the company has already made a change, or they've submitted a work order. We can put a work order number in, whatever level of detail the customer wants there. And we can snooze that for, say, 7, 14 days. If they say we're not going to touch this thing until it gets worse, or we do our next service in 30 days, then we'll snooze it for 30 days. If the severity increases and it goes from a high alarm to a high alarm, then we would actually go ahead and it'll re-trigger the alarm, so you don't have to worry about not noticing things getting worse during that time period. We can also acknowledge alarms. So some alarms are set in such a way that we want to know that the alarm was met, but it may not be entirely repeatable all day, every day. So something like a rod load condition, where conditions change in the pipeline and you have a increase in rod load in the middle of the night, you don't want to not know that that alarm went off because you go to your dashboard and it's not currently happening, so it's not there. So we can make an alarm acknowledgeable or latching. And then we go ahead and you actually have to go in and say, I've seen this alarm, and you put a comment what you did about it, or that you noted it, or whatever, and that way none of those conditions go unnoticed. And that allows us to then have an alarm log that allows you to see what sort of things haven't been paid attention to already. So the more complex alarms we can actually build with formulas and trigger delays. And this would be an example of a leak index, or a leak monitoring alarm that we use in Enterprise. And what this does is say, okay, I want to look at one trend value, but I don't want to only get alarmed if one trend value meets a condition. I want to also know if a second value meets a condition. And then you could do a third or fourth or fifth value. Or you can say, okay, I want to have a qualifier for a certain set of thresholds. So in this instance, again, if you're familiar with compressor analysis, be a little bit more familiar with you. But in this instance, we say that because we know when a leak pops up, we expect to see a spike in flow balance and a spike in N ratio. We make sure that we either have to have a high measurement on flow balance and a high measurement on N ratio, or a low measurement as well. And then because of the discharge volumetric efficiency having an effect on the level of accuracy of the data, we know that if we have a very small portion of the stroke is being used to actually push gas out of the cylinder, that we can have a little bit of variance in our data. So we actually can make the thresholds a little bit looser under those conditions. So this particular alarm would check flow balance and N ratio and make sure that they're both above the threshold. And then it would also say, but only use these thresholds if our volumetric efficiency is over 20%, under 20%. And the possibilities of how you could configure these are endless. We also have the ability to tag these as what type of alarm they are, so that way you know when you get your email what to be concerned about, and then how critical that alarm is in case you're not the person that set it up originally, but you need to act on that alarm. And then again, depending on the service interval, like Sally, you had mentioned, some of these you're just getting the data delivered and you're doing all these insights on your own, or on the higher packages, we're doing these insights for you. And then we can also trigger a number of alarms, a number of occurrences before this actually trigger you. So a valve leak is typically extremely repeatable. And if it happened 1 hour and it's really a leak, it will happen 2, 3, and 4 hours later. And so we can set this to say, okay, once that leak has been identified for 4 hours, then you notify me about it. And in the same fashion, if you don't have 4 scans in a row with it out of alarm, it won't turn that alarm off either. So that way, if you have something right on the threshold bouncing in and out, you're less likely to get repeat notifications of the same condition. And then, of course, now we've gone and we've looked at all this data. We've gone through and analyzed it and dug into all the nitty-gritty on it. And now what really matters to most people is, what do I need to do about this? And so all of this information is reported to the customer in a couple different ways. The first is your 24-hour health status. This is one of the tiles on the asset overview page. And basically it gives you a report out of all this hardware sensor health. And then if you have any actual alarms that have gone off based on performance, they're reported here as well. We can run that for any single day whenever you want. And you can generate into a nice pretty PDF, so that way you can hand that up to the people who are making decisions, or the people who are wanting to know overall health of their units and all of that. And then we have a periodic report that we can generate as well, that looks at the fleet as a whole and kind of summarizes, these are the assets that have things that need to be paid attention to. These are the assets that are fine. We have fleet-based metrics in there as well, so we can say these assets are performing more efficiently, less efficiently than others, and gives you just kind of an idea of, okay, I've got information on 100 assets. What do I do about it? Where do I need to focus my attention? If you're a higher level organizational person and you're not the person that's actually working on one specific unit, but you want to know everything in the fleet that's monitored by 5 different analysts. And then when we actually do find a fault, of course, we go ahead and we write up a report on that. And it's just a basic report that gives you the details of what we're concerned about, what sort of timeline we think should be taken on that, and we make recommendations there. And we, of course, provide some evidence and a description of what's going on. And then once we get feedback from a customer that an issue has actually been resolved and they've told us what they found, then we can also resubmit that report with follow-up findings and cost savings. So that's kind of the rundown of what we do with all this data, how it gets utilized, and everything else. And so next, I want to kind of open up and give an opportunity to see if there's any questions that we want to answer live real quick before we go into the demo.
Yeah, I think you caused a lot of people to ask questions, so we've been trying our best to answer them live, but I'm sorry, through text, but a few will answer live. So Sally, you wanted to answer a couple of them, so why don't you go ahead?
You're on mute, Sally.
All right, thank you. So one of the question was about our system being able to do shutdown. So Pete, do you want to take this, or do you want me to answer this live?
Yeah, I can mention this. So we do not, with Spotlight, we do not do any shutdowns. This is a monitoring only technology. So any shutdown activity would have to be a result of a notification being received and then an action being taken manually. So we do have products that do shut down. We have Platinum, which is a critical asset monitoring system, and that does have shutdowns and a number of other things, but this is strictly monitoring. It does not interact with your equipment at all. Yeah, I think that answers that question there. So, and the customer can receive notifications just like we're receiving notifications, or you can choose to not get the actual notifications and only be notified by us when we find something that you know, and we submit a report to you or whatever. Different customers have different preferences on that.
There was.
Go ahead.
There was also a question regarding Kenny, and one of the question was, does Kenny only being offered as a service, or can it also be available to partner in order to integrate it with their own asset and services? So the answer for that is Kenny is available to all customer depending on the service offering that they select. But as I mentioned in one of the slides, we are also collaborating with customers and doing a lot of partnership with other companies. So we did a partnership with DCP where we developing AI models and predictive analysis, trend and in order to kind of better the reliability program as well. Pierre, do you want to add something to this?
Yes, that one actually specifically, we know that the cause of problems of machinery are not just always inherent to the machine, but as they say, machines don't die, they're killed. There's always the process. So the work that we're doing with them is to develop models that help you predict by starting to look at the process, let's say upstream. So
okay.
There are a couple of other questions also around ProFlow EOS. Maybe Salio, you're best to provide that info as to how does it work, how does it connect, and also what parameters. There were two different questions, so go ahead.
So ProFlow is a device that can be attached to any compressor. So it's a lubrication device. So what we do is we connect that device to our gateway, and also in order to train data directly to our enterprise software. So we are able to build dashboards specifically related to that lubrication device. So we connect that, and we also correlate those data with the behavior of the compressor. So the main idea here is to reduce the lubrication cost of customers, because sometimes customers end up over lubricating the compressor when they don't have to, which can also create some damages to the compressor. So that's what we do with our ProFlow system. And ProFlow is from our partner, CPI.
A few of them are on actually. And a couple of others. One is, I'll go on a limb here. What is the maximum timeline to retrieve old alarm event history? Pete, jump in, but I think it's infinite, right? But go ahead and tell us how it works and why.
Where was that question in the panel?
So it's actually, we're getting questions on both sides. So this is on the Zoom webinar chat.
On the chat window? Okay, can you just repeat it again? So I'm trying to find it.
Timeline to retrieve old alarm event history.
Okay, so currently we haven't started archiving anything yet. We have data that's up to over 2 years old at this point. But we will have an archiving system in place. So if you get over a couple of years, you'll have to basically request the old data. But I believe that the intention is that we'll always keep at least 2 years of data immediately accessible.
Okay. I'll take this next one here. Can this predictive system send info to SAP? There were a couple of questions on that. So we do send data to CMMS systems. And we do have customers that, for example, configure it for a level 3 leak, immediately start a work order, and dispatch resources to go either take data or even order the parts. So yes, that link does exist, and so it goes full circle.
And I see also a couple more questions. One of them is related to 6400, and the question says, normally with WinRock 6400, we find the theoretical frequency with the supply data, but can we install a compressor gas volume measurement sensor to get a real value of the million cubic square feet?
So I think by theoretical frequency, I'm thinking that's theoretical clearance based on the context of the question. And so right now, we just like on 6400, we are calculating the clearance in a cylinder. We do have the ability, if you have a external sensor being fed in through Pi or something, we have the capability of feeding Pi data into the system, and you'll be able to view it alongside. but currently the calculations for performance and everything else would be based on the calculated clearance that's measured in the software, just like on your 6400.
There's another question. Oh, I see. Pierre just answered that question. The question was, do we have any local contact in the Middle East? The answer to that is yes, we do have some local sales representative in the Middle East as well.
Yeah, and Samir's actually on the call right now asking questions as well. So we can definitely get you in touch. Just send us an email and we can get you in touch with your local contacts for sure. Anything else we want to touch on right now before going into our demo?
Yeah, so let's go do the demo, and I'm sure there will be more questions. And so let's try to leave a few minutes for that.
Okay. All right. So here is a sample customer. This is a hydrogen plant. We've got two different hydrogen compressors, a 2-cylinder and a 4-cylinder. Of course, we've got this located at the Winrock office in Knoxville, Tennessee right now, just for the sake of demonstration purposes. But if you do have assets spread out over a variety of areas, you get a nice convenient map where you can see kind of where things are. We have multiple ways to get to navigate. Just like any good system, there's multiple ways to navigate through and find the information that you want. So in this instance, if you want to go into one of these compressors and you want to view the asset detail page that we talked about in the presentation, you can come here to the actual icon on the map, and when you click on it, you get a little spider out, and you have the machine. You can go to the asset detail page. You can go directly to the analyze page. You can leave notes on the machine as well, and you can do that for each of them. There's actually typically in the production environment, you would see a link here to the advanced analytics as well. We don't have that running in the demo environment, but we'll show you that dashboard here in a minute. So we can come here to the detail page, and we can see exactly what we were just talking about with a real machine, real data. This is coming in live right now off a compressor that is actually out there in the world. And you see we have 2 alarms that are currently active on this machine, and in the last 7 days they have been active. You can see that the efficiency, this particular has an electric driver, so it is costing them $131 to move 100 million standard cubic feet of hydrogen. And in the last 7 days, that's been the same basic cost. Horsepower utilization, they've actually had a few cylinders that ends were deactivated, so they've actually had big changes in their utilization in the last 7 days, and you see that here on the graph. You can mouse over each of these points and see your values and see your current day and your last 7 days as well. And the same thing with capacity. You can see here that we had an alarm pop up yesterday at 11 a.m. Every one of these can be moused over. You can click in these and you can see percentage of time in the last 7 days that the unit's been an alarm if it happens to be an intermittent condition. Again, as we talked about, every single one of these little slices here represents 1 hour of data delivery, and if we miss even one single scan, it will show up here. And then the hardware health, we can see here there's certain conditions we can't measure if the machine's not running, because we don't take pressure measurements and that sort of thing. So the system reports back as agnostic with a little gray line on the hardware health when the machine's not running, and those are shown there. We come down, of course, we have these graphs, just like we talked about. All of these can be moused over. Right now, this is measuring per day, and we're only scanning once per day, so all 3 of these values are the same. But if we were to run at a faster frequency, like every 5 minutes, you would actually see a spread of your high, low, and average over the course of that hour. We see here that we have the 2 alarms that are active. We can see when they were created. We can mouse over here and we can see it was a low alarm. It was triggered a day ago. The last one came in 11 minutes ago. If we have any reports here, so in this case, the actual customer here has the report already uploaded on this. The leak's actually been there for a few days, but in this demo environment, we don't have any reports yet, so we can kind of walk you through how that works. But we have these 2 alarms that are active. We can see the 1 hour where we didn't get an RPM on the machine. We do know that the machine was communicating because we don't have a slice here showing us that we didn't receive data. We just didn't receive an RPM on that data. So we don't evaluate the hardware health at this time when the machine's not running. And then we can see here all the way back to 23 hours ago, we've had this alarm has been active, and you can mouse over here and you can see how many alarms were raised. You can see the time, and then the alarm value is at the end there. It says 0.9180. So that is your flow balance measurement for that scan. And you can see how that may be changing over time. And then down here, this is our little Kenny AI summary. We can see here that we do have a report out on cylinder 2, which is consistent with the information that we have here. And so this is where we would kind of start to do our investigation. You know, normally we would probably actually already know about this before it pops up, because we would have had a prediction from Kenny depending on its confidence level. And he's pretty humble. He doesn't say he's super confident unless he really is super confident. Well, that's frustrating. Let me see here. Let me pull that up on the other screen. I'll pull that back over. I've had it up too long and timed out on me. Please hold.
Maybe we can take advantage of that to answer a couple of questions.
Absolutely.
Yeah. There was one question around the maximum distance. I'll be honest, I do not know the answer to it. I wonder if
EOS is connecting to our gateway through Wi-Fi, right? Or is it hardwired?
it was different. It was what is the maximum distance we can plate the CPI junction box? So the maximum distance.
Yeah, so if it's coming through Wi-Fi, which I'm pretty sure that one is, you know, think of it as like your home Wi-Fi network. If you have open space and there's no equipment in between the device and the gateway, you have a typical Wi-Fi range. It's a broadcasting its own Wi-Fi network. It is going to be subject to mechanical noise, physical objects in the way. Line of sight is going to get you the best range. I think we say typically about 90 feet, 30 yards with a clean is what we say. I think we've had success with higher than that, but it's not official.
And then there was another question I can go ahead and answer. So can you change the scanning rate instead of 1 hour? I think the highest scanning rate we used is about 5 minutes. Of course, as you do that, you get more data, but there's also more of a data cost, right? As we also have to pay for the LTE service.
Correct. The we can go on high-speed engine. The collection times are a little bit longer because we collect a lot of long waveforms, so we can typically go about 10 minutes on that. And on Spotlight, we can go down to every 5 minutes. Majority of the time we run once an hour, and we haven't seen a need to do that unless we have a condition starts to pop up. And in that which case we go ahead and increase the polling interval to get a higher resolution picture of what's going on. And we've done that in a number of cases. And then typically once that problem is resolved, we'll go ahead and back it back off. But for typical monitoring, we haven't seen any need to go more than once an hour to get the data we need to have confident monitoring.
Yeah. And there was another question, the POC to control a wired connection, is it unlimited?
POC to,
I think the question is how many pucks can you connect?
oh, okay. So yeah, so each controller supports up to 4 cylinders, 4 pucks, and then we can have multiple controllers linked together for the same system. So if you have a 6-cylinder or an 8-cylinder, we just have 2 controllers working with that, and then you know, it's a Wi-Fi system, so we have the ability to connect a lot of edge devices into one gateway. As long as you have, typically the restriction is more of the range, how far away they are from the gateway, rather than how many devices can physically connect to it.
Yeah. So another one was, how does data lost or loss of communication appear in the system? You want to take that one, Pete?
Yeah. So on our operations dashboard, if you have a unit that is not communicating, it will show up right here as a red item here, and it has to go more than, I think currently it's like 3 or 4 hours without receiving any data, because sometimes we do have hiccups in cellular connections, and it can we can have data kind of backfill. If we have a loss of cellular connection, the system does have a multiple cache system, so it can cache on the collection device, it can cache on the transmission device, and then when it does reestablish a connection, whether it's the Wi-Fi connection is broken or the cellular connection is broken, it will go in and backfill all that data. And as long as it was physically collecting, we don't end up with any data loss. But it would show up here as a red, and you can go through, and if you had a large fleet, you can go through and filter for just units that are not communicating and see if you had any of that. We're of course monitoring that very closely all the time as well. We have a very base level dashboard that we use that shows every 4 minutes connectivity, just a quick check-in. So we are very hyper aware of whether or not the units are communicating, and if we see an issue, we notify the customer right away to see what sort of action we need to take.
Very good.
Okay, I'm back and relogged in here, and
let's maybe take out this last question here.
Oh, sorry.
This one, yeah. So the maximum cylinders on a Spotlight can be 4 cylinders, or would you need a second system for 8 cylinders? So if you want to maybe answer that.
So yeah, per controller it's 4 cylinders, but we can link multiple controllers together. So as big as they make compressors, we can outfit it with a Spotlight. It's not a problem. All right. So we come down here to our AI health status, and I want to show this screen off real quick here, and then we're actually getting pretty low on time, so I want to dive into the advanced analysis tool as well real quick. So I didn't realize it was quite as late as it was, but we've already done a bunch of our question answering ahead of time, so that's good. We're a little ahead of schedule in that sense. So this is the interface for Kenny. As soon as it comes up. Now, and you see there's a beta tag over here. The AI running in the background is not beta, but the user interface is beta. We're working on developing this right now, so that way the customer can provide input to it. Come on. There we go. All right, so that's what I get for being impatient. My dad's watching. Sorry, Dad, for being impatient. That pulls up here. I will pull over the advanced analytics dashboard real quick. I don't know why it's hanging up. It's usually.
While we wait, there's a couple of other questions. Can this work on large diesel power generators? So we typically use our portable instrument, the 6400 on that. We can do some basic analytics on those as well.
Yeah, the high-speed engine, we don't have any diesels out there yet, but the basic technology, there's no reason why it can't be used on diesel. I can talk a little bit on that real quick if you want. The way that we do high-speed engine monitoring is, we're not taking pressures on that. We're just doing vibration monitoring only. And what we can do is we can actually take one revolution of the crank and we can monitor the overall vibration level of a certain band of degrees. And we can set up that around the typical valve event. We can set it up around an early period and a late period. And then we can trend that overall measurement. And as we see the overall vibration value start to drift from your typical band to an early or a late band, then we can start to have an idea that we need to go look closer at at that data.
And since we time is running short, there's a couple more questions to make sure we answer. So can the platform accept 6400 data to analyze more complex data coming from other sensors?
Yes, so we have a 6400 product as well that allows us to upload all the trend data. So it's just like with Spotlight, we're not uploading the raw data for analysis on the web, but we can upload all the trend data that comes out. So all the values on your compressor report or your engine report, they can all go up there, and then you can do comparisons across machines. You can pull up reports or trends very quickly for assets that you may not have taken data on, and that sort of thing. But yeah, we do have the ability to connect those together.
So there was also a question on pumps. I'll try to answer that, but just high level, we can do basic vibration information on reciprocating pumps and tying that to crank angle. We can also do some basic analytics using our Spotlight. The Spotlight for engine actually connects to accelerometers, so you can use those accelerometers to come up with the basic analytics on dry running and cavitation, etc. So it's a doable application. We haven't really ventured into that, but it's absolutely doable.
Okay, this came back up. We've got 4 minutes, so I want to just dive in real quick to how we give feedback into the AI system, because this is really cool that this is something that's visible to the customer. So when we come in and say, I want to verify this particular alarm, I can come in and I can say, you know, whether I need to continue monitoring this to know if it's really going to be an issue. So if it's an early call and we don't see any indication in the data yet, we're going to mark this as needs monitoring, because we're not going to be able to tell Kenny he was right until we actually see it happen, of course. But if it's something that's already happening, and you know, if he's saying that basically you're going to stay at status quo for a little while, this leak is going to just persist, then we can mark it as an issue, not an issue. So here we're going to say, okay, this is an issue. We don't have time to get into it, but I've already validated this. It is a legitimate discharge leak. It's actually on both ends of the cylinder. So we can come in here and we can say, all right, this started on the 15th, and the last occurrence as of right now is on the 16th, and it occurred on the crank end, and it also occurred on the head end, and we're going to call this, it's a level 1 leak. And then we can say either this needs verification, needs monitoring, you know, and this is the same basic options from here, but this is on the cylinder level or the asset level. So now we know, okay, there is an issue at the asset level. So we flag that. We can say your comment here, if there's anything that we want the customer to see when they go look, or another analyst, and we hit submit. And what's going to happen here is it's going to pop up right down here with the feedback that we gave the system is directly visible to the customer. So again, that whole laying all of our cards out on the table. And again, I apologize for the lag time here. We are using the test environment, and sometimes we've got stuff that hasn't been fully proven out. This is the reason it's not in production, and we can get a couple things cause long load times. So I apologize about that. But as soon as this finishes here, you'll see that comment there, and that's the primary stuff I wanted to touch on. Again, we've had other webinars on how you use MD. Just knowing that we can go into MD and validate all of this stuff is important, and we can get you the other webinars on compressor or engine health analysis through MD as well. There we go. And we have all that information is available to the customer.
Yeah. So we're coming up to the end of this. Thanks everybody for the great participation. A ton of questions have been fantastic. There's going to be a survey link at the end of this, so please take a couple of minutes to give us your feedback. We really appreciate it. Pete and Sally, you any comments on your side?
I do want to mention next week's webinar with our 1 remaining minute. Next week will be Winrock Services. Eric Vest, who's the field service manager, and Tony Hernandez, sales application engineer. They'll be talking about all of the things that we can do if you don't want to have a subject matter expert on hand that can do this analysis, and you want somebody to come periodically to your facility and look at the machines and just tell you what you need to do. They will go through all the different offerings that are available there. We'll see links for that come out here at the end of the week. There'll be LinkedIn, Facebook, direct to email. However you found this link, you'll probably find that one in the same place. And then what we've done on these past ones, the Zoom will cut us off, but it's not typically exactly 1 hour. We get a little bit of wiggle room, so we can sit here and work through some more of these questions